All right, any questions from yesterday? Okay, so remember your exam is Monday over special senses and hematology. Same general format as the last one. You know, lecture after the exam, so you're done. You can get up and go. Last two things we're going to talk about in hematology is blood clotting, which is referred to as hemostasis. Hemo meaning blood, stasis meaning the stopping of, so stopping blood. We're not talking about stopping it from the standpoint of going round and round. We're talking about stopping it from leaking out of a blood vessel. And then the last thing we're going to talk about is our blood types, often just referred to as our ABOs. Type A, type AB, type O. And then we'll talk about the RH factors and how that plays a role in some of the ways we treat patients. So the first part of hemostasis, there's going to be three components. Okay, and again, as you start to study, as you start to make your notes, you know, when you hear hemostasis in three, then you should be probably thinking three things that you're going to be having to regurgitate at some point. Okay, and just as a side note, I've already said this, but this is again not homeostasis. Homeostasis is what happens in your house if you have an air conditioner and a furnace. You set your thermostat at between 69 and 72. That's homeostasis. If it gets warmer than 72, the air conditioner is going to kick on and bring you back into the range of 69 to 72. If your house gets too cold, then the air conditioner turns off and the furnace comes on and brings you back up. So that's the homeostasis. Okay? Every body system has that. This is hemostasis. So again, I want to make sure that's clear. So the first component of it is called the vascular spasm. Okay? So immediately, if there is a cut in the blood vessel, your blood vessel, as I kind of alluded to the other day, is essentially three layers. We'll talk about this to a greater degree when we get into the vascular chapter. But we have three different tunics. We have the adventitia, we have the tunica media, and then we have the tunica interna, or the tunica intima. You don't have to write those down. The key part about it is that the tunica media, the middle one, is smooth muscle. Which hopefully you remember we don't have control over. Smooth muscle is an involuntary process. So when there is a cut to a blood vessel, then the smooth muscle will contract, thereby causing what's referred to as vasoconstriction. Vasoconstriction just simply means that the blood vessel diameter is getting smaller, if not totally absent. This particular process is probably best in the smaller vessels. It's the strongest in the smaller vessels. And it's also the strongest when a greater amount of the vessel is damaged. So probably the area that we see this the most would be a crush injury, because it's usually going to be the smaller blood vessels out here, and there's a greater amount of damage. It's not just a slice. Okay? Now, this obviously wouldn't work in the larger blood vessels because they're too big. So the biggest blood vessel in your body is the aorta, and it's about an inch in diameter. That would take an awful lot of muscle to squeeze down. Now, there's also another reason why we wouldn't do this. This is the main pipe that takes blood to the rest of the body. If it's squeezed down, blood wouldn't go round and round, and you would die. Kind of defeats the purpose of stopping. It's a rather extreme measure to stop yourself from bleeding to death, is to kill yourself. Okay? So the body's not going to do that. So this plays a much, much bigger role, again, in the smaller blood vessels with the greatest amount of damage. Now, the second process is going to be called the platelet plug formation. Okay? So again, there's three mechanisms here that we're going to be talking about. Now, platelets, in and of themselves, are they're basically smooth. They're considered to be inactive unless something turns them on. Okay? And usually what turns them on is going to be, and when I mean turn them on, I mean activate them, is a collagen fiber. So remember going back to your AMP1 when we talked about histology, collagen will be a major histological form that makes up some of the walls of the blood vessels. So if there's damage and collagen is in here, comes in contact with platelets, then the platelets, when activated, become spiky. So they form little processes on themselves. They release all sorts of chemicals that are on the inside of them. And I'm going to talk about 3 that you're going to need to be familiar with. And there is a chemical called a Van Willebrand factor, and it is also, it swims around in the plasma. It is also activated by endothelial cells, broken endothelial cells. And what it does is it facilitates platelets coming together. So normally platelets are not going to be active. They're not going to want to stick together, primarily because we have, again, remember from the other day when we had this conversation, we have these endothelial cells. These endothelial cells secrete a chemical called prostacyclin. Now, if you've ever heard of the term of a prostaglandin, this is a form of a prostaglandin. There are different classes of prostaglandins. This inhibits platelets from becoming active. That's why they don't just start a clotting process. Okay? Nitric oxide, same type of a process. Prevents activation of our platelets. So, if I have damaged endothelial cells, they actually will activate this von Willebrand factor. And what the von Willebrand factor does is it allows for activated platelets to come together. Okay? We're forming a plug. Platelet plug. The platelets should be coming together. Okay? Now, if you remember back to ANP1, we talked about different feedback mechanisms, and I've kind of talked a little bit about it in this term. There are 2 primary feedback mechanisms. There's a negative feedback mechanism, which are the most common in the body. Okay? And again, I'll give you a non-physiologic example of a negative feedback mechanism, and I just talked about it 3 minutes ago. The air conditioner in your house. So if your house gets hotter and it moves the temperature over here, a negative feedback mechanism is going to move your temperature back in the direction from whence it came. Okay? And that should make sense that that's the most common. Positive feedback mechanisms are if I was to stand here and I got moved in this position, instead of moving back there, the body is going to continue to move me in this position. And there's 2 primary examples of that. One is childbirth. When you start to have contractions, contractions cause oxytocin release. Oxytocin causes more contractions. More contractions causes more oxytocin release, which causes more contractions. So that's going to continue along until the baby is delivered. Platelet activation is the same thing. When I activate platelets, they turn around and activate more platelets. It's like we have a problem. Why don't you guys come on over and help a little bit? Now, the primary thing that's going to cause this to occur is going to be these chemicals that are released from the platelets once they're activated. Okay? So again, platelets are probably going to be activated by collagen fibers from the cut. There are other things that can activate them, by the way, but collagen is probably the easiest one to talk about. And then they will form processes. That's what I mean by they get kind of spiky, and they will release chemicals. This is going to allow them to start sticking together. Now, the 3 chemicals I want you to be familiar with, the first one is serotonin. Now, as you start to go through your anatomy sequence, you're going to realize that there are different types of serotonin. So, we talk about selective serotonin reuptake inhibitors, people that are on antidepressants. Okay, and we alluded to this in ANP1 when we talked about the nervous system and kind of how the process works. And I'm going to tell you what it does at the end. I'm going to just kind of describe these 3 things, and I'm going to tell you a nice, easy way to remember them, okay, and what they do. ADP, adenosine diphosphate. And the last one is called thromboxane A2. Thromboxane A2 comes from a cascade process with endothelial cells once it gets activated. Now, the first process, the first step in hemostasis was vascular spasm. Serotonin. S and spasm. Serotonin increases the vascular spasm. So we create the spasm, we move on to the next step, which is the platelet plug formation. The chemical that's released from the platelets goes back up and enhances the spasm. So S and S. Now your book's going to differ a little bit on this. It's not a different way of looking at it. The way that I teach it, I think makes it easier to remember. Okay? Now, ADP, adenosine diphosphate. What did I say the platelets were going to do? It's a platelet plug. They're going to call other platelets to the area because it's a positive feedback mechanism. When things start coming together, they aggregate. Okay? Aggregation, ADP. Both start with the letter A. Thromboxane A2 has two roles, spasm and aggregation. Now, this prostaglandin right here is the prostacyclin that I was talking about. So the one in your notes where it says prostaglandin, if you want to write prostacyclin, that's fine. Prostacyclin might show up on the exam as opposed to prostaglandin, so you might want to put in your notes that prostacyclin is the same thing as prostaglandin. And again, if you do any advanced reading, what you'll find is that there are different classes